I welcome Sridhar sir for this podcast. This is a podcast where I was always waiting to do. It's not about doing with an solution architect or as a cloud advocate or anybody. It's all about doing with an engineer. And I needed some right engineering approaches. And over a course of time, met hundreds of engineers and thousands of people who are very enthusiastic about it. But trust me, to get some right insights, you need some right engineers. So I'm honored to have Sridhar sir on this podcast. And thank you so much for giving this podcast, sir. Means a lot.
Thank you, Vishwas. Thank you for having me.
Yes. So let's just start with your journey as a student and that professional life which molds us as a person. So I just want to demystify that factor before we get in, because a lot of times we don't understand what really happened to build us as such a calibered engineer or something, or else a tuned engineer. But I wanted to really get to know what was your journey as a student and as a professional.
Absolutely. I think I have to go back or rewind at least 2 decades if I have to go back to my student life. So I have been in the industry for about 23 years now. So if I have to go back 23 years, I would be finishing my engineering in Chennai, Bharat Institute of Science and Technology as an electronics and communication engineer. So I was so passionate about electronics at that time. Those are the times even before we thought computer and anything related to computers and networking as a profession. So it was the time where it was all about electronics, mechanical engineering, and civil engineering. So there used to be good amount of competition to get into some of these courses, but I was lucky enough to be on the electronics and communication batch. And of course, that was my primary interest. So with that interest is where I entered into the professional life. So my first job was in an R&D in one of the organization building microcontroller devices and designing vending machine motherboards at that point in time. So that was a very short time, but of course I very quickly moved into IT, and I've been doing different types of jobs within IT. I've been in various capacities covering both engineering on the product side, as well as I've been on the support engineering side of things. I've been on sales and pre-sales, and of course on the architecture side of things. I've been running large teams as well as part of some of my portfolio, building managed services even before the days of cloud, where it was called hosting, and now it still exists, but cloud is becoming a lot more common terminology. So I do work for Microsoft now as a solution architect covering data and AI. More my favorite topic, I would think. Given that I have an electronics background, I would always want to go back and work on something related to electronics and machine learning and AI, which is a right kind of combination that feeds back into my interest and hobby that I do all the time. So by the way, anything I say is my personal opinion here, and it does not represent anything from my employer, Microsoft, at this stage. So I do a lot of forums, and I do have a bit of a presence in social media. So, but everything is my personal view, I would say. Yeah, and now I'm here talking to young professional like yourself and getting into the industry. So I'm excited to be here.
Thank you so much, sir. Thank you so much. I think that's what it is all about. That learning that you have when you are very small, that influential person that you meet. I think probably that's going to change your mindset. I think probably what's your view on the solution that we are architecting today? Like today we are driving some key factors. Your view about the solution that is driving the world using the AI. What is it all about? Because probably you have not seen AI to the extent that we are seeing, because everything is AI today. I just opened my phone, it was an AI, which is just give me, okay, you have a message here, just go there. And probably we are connected because of some artificial neural network, which is manipulating some sort of a data in and out of the network infrastructure that we're talking. So I want your view about the solution that we are developing using AI today.
Absolutely. I think AI is becoming increasingly popular. I think it's because of the fact that we are highly connected these days. It took so much long time for computers to be a common thing across everyone's house. But I think cloud made it much faster, internet made it much faster before that. And I think AI is going to become even more faster than this. I think there are two important reasons for that. One is the popularity and reachability and familiarity that people get as part of the media and exposure into some of these subjects. The curriculums are changing much faster. So students are and young professionals, they are learning this much faster in their academics as compared to what we used to do long time ago. It takes quite a bit of cycles before our syllabus would change. But I think in these days, it's a lot more quicker and swifter in terms of how quickly younger generations are reading about latest technology. And thinking of solutions itself, I think AI or machine learning is one such technology that's a lot more affordable and reachable in these days because of the cloud as the backend, because so you need a lot of compute and a lot of energy resource for it to run and train models and bring it into action. And that's becoming much more easier with a lot more availability and ubiquitous presence of cloud. So anyone can get started very easily. And the second important portion is the concept of open solutions, right? So open source that are available and how people can readily use some of these technology to quickly get started, and the enormous amount of learning materials that's available on the internet. So I would imagine more than the professionals who are working on these technology, everyone else would be well informed about this technology because they can learn it all right from the media and from the computers and from the internet, I mean. So I think all of these are influencing the quicker adoption and quicker exposure of these technology. And that's another reason why we start thinking of employing these technologies in as much areas as we can. So that includes anything from commercial applications that you see on your phone, or it could be an industrial implementation. It could be a corporate implementation of technology within an enterprise. So it covers all sectors of our life, including entertainment, all the way through education to retail and medical industry, so which is healthcare, finance sectors today, and of course on entertainment as well. So today a lot of the gaming that happens is all AI infused. The stuff that we do on internet is a lot more on AI. So I think those are some quicker reasons as compared to earlier technologies, which took a lot more time to reach. This is all about open source, easier access to technology, people learn it quicker, and it's commercially viable for them to quickly infuse some of these into their applications as well. A lot of these are purpose driven. Of course, it's purpose driven, but we also have some challenges around these in terms of how these are very quickly adopted. So if I have to do an analogy, think of vaccinations that were taking like 10 or 20 years to develop a vaccination for a given condition. Today we are able to do that much faster. So while technologically it's possible, people still have those doubts of, this has been done so quickly. Is that good enough for us? Is that safe enough for us? I think AI and ML is also in that state where we have quickly adopted some of these technology. It's commonly found everywhere, but still there are a lot of controls and the legal framework that needs to be in place in using some of these technology, because with every new technology there is a darker side as well. So we wanted to make sure it's used in the right way and for the right purpose.
But I wanted to understand, like, we have an easy accessibility of all these intelligence. Like when you think of customer stories from Microsoft itself, there are amazing case studies which have been already been pioneered by a lot of engineers who use the same technology which existed, but bought it in a different form factor. But I feel that somewhere we have not architected some solution in a very right fashion. What do you think about the way we are architecting a solution using AI today? Because not just IoT solutions, which are throwing in tons and tons of data, but we are now in a phase in which we are supposed to get some insights out of it. So I wanted to know, how are we architecting it? How is it going on in the world? Because I want that understanding of, are we doing it the right way, or is there something to be fine-tuned from the engineering approach that you have seen? Because you have met a lot of startups, a lot of engineers. What is it all about according to you?
Yeah, I think it's still in its infancy in terms of the maturity and how well we can do this, because a lot of these technologies are still evolving, I would think. And while it's evolving, it's already put into production in a lot of these scenarios, right? So people are already starting to use image recognition, things that you do for identifying the age of a person. So all of these are using some level of AI and cognitive services in the back end. While these technologies are still evolving, I would say, that's actually posing a challenge, because it's a moving target. So the technology is evolving at one stage, but interestingly, there has been a lot of adoption. Usually, if you see the hype cycle, any product goes through a sequence of steps or stages, but sometimes you will see some of these, like AI and ML, has a short circuit in terms of how people suddenly jump into it and start finding a lot more applicability of these technology. So in short, I think it's definitely evolving, and people are already putting their hands on these evolving technology. So the risk that we see as part of this is the missing framework around this, which governs some of these factors, like fairness, inclusiveness of how we want to make sure some of these technology are covering every sector of the generations that we have. And at the same time, we are already having challenges around transparency, privacy, and security in a lot of the technologies related to the internet. So with AI and ML, it becomes a lot more important, because AI and ML is primarily driven by data. Any model, any AI-based solution is as good as its own data itself. So the way we train the model, the way we train the AI system is highly dependent on the quality and the type of data that we have. So given that we have just recently, or maybe a few years back, we have started gathering a lot more data as compared to what we did a few decades ago. I think with a lot more influx of that data, all these getting lit up because of the data that we are collecting. But at the same time, the governance around the data, the governance around the applicability of the solution itself is not yet being fully matured. So even before that, we are already starting to put this into action. So we have already seen there are some repercussions because of this, because of the system that's been developed. So if I take a simple example, when you're trying to do facial recognition, we don't have law and enforcements which are a common framework yet around privacy and facial recognition as a technology. So there are missing legal frameworks around this, and starting to use some of these technology even before that matures could be a big challenge, both from a legal perspective, from privacy and reliability perspective as well. So a lot of these frameworks have to be in place so that we take into account of all of these structures. So one of the things we always recommend is to build a responsible AI. And that covers how we have a fair share of all the data types that is needed. If I give an example on fairness, are we training the system with the data that's relevant to all parts of the generation, all parts of the people around the world, different kind of people and country and race, gender. So it includes everything in terms of giving a fair share of participation for a lot of these a lot of these contributors. So it's all in the form of data. For example, if I train a system only with a lot more data, which talks about a female as a gender, and miss out a little bit on the male, so the trained AI system is already skewed towards data that's more aligned to female as a gender. So this is just an example, and there are so many unconscious bias that can get into the data, which can lead into a faulty system, which when put in production could be even more dangerous in terms of how we are driving the effect of these solutions in the community. So fairness is an important piece. Again, inclusiveness, including everything, whether they are physically challenged. So accessibility for everyone. So in design, when an engineer designs the solution, I think it's important to cover all of these, and most of the large organizations, you will see inclusiveness is an important piece. Accessibility, whether you have a dark mode of your screen, or you have a color combination that's more conducive for someone with night blindness. So all of these are a part of designing a system. And of course, with AI, it's a lot more important to have transparency. I think based on what we are designing as a solution, that needs to be a lot more transparent, because it's making a decision on behalf of humans. So if we are thinking of a prediction system, so we are expecting the system to understand all the parameters and features around the data and to do a prediction around that. And in finance sector, we are seeing they are increasingly using this for credit scoring, for fraud detection. So we wanted to make sure it's not wrongly identifying someone to be an incorrect entity within that equation. So transparency on how some of these systems are designed, which exposes the kind of bias that might exist in the training or in the model. That's an important piece, so that people can understand what does the system really do. So it can't be a black box model. So that's something I would always advocate for engineers who are building this AI system. So a lot more transparency is important. And security and safety and reliability is a given factor for anything. Just imagine the safety aspects that's needed in an autonomous car, which is driving by itself. So all of these are an important factor that we need to take into account. And accountability, nonetheless, the accountability is an important piece. With a given open source model that we are increasingly seeing, accountability becomes a big challenge. So we want someone who owns the entity, so that some of these decision-making systems can be held responsible for anything that can go wrong, so that it can be corrected by the accountable person. So taking accountability of what's happening within the system and the design, that's a very important factor. So I think these are some 5 to 6 important principles that needs to be kept in mind, especially when it comes to AI, so that a right system can be built and a right control system can be brought in place for these entities. Are the current designs following this? Yes, theoretically, but as they start going into production, as they start going into implementation, we're going to see a lot more challenges. As I said, there are systems that could be designed for one part of the world, but because of the connectivity that we have, because of the connected world, probably someone might try to implement the same solution onto a different demographic, which might not be a suitable solution in that geography, for example. So that needs a constant check to make sure the system is being trained for the demographics of that particular region where you're trying to roll out that particular solution. So a constant feedback system needs to happen. So like in any DevOps procedure where you are managing and maintaining the release management of the solution, MLOps is an important piece. So we need to make sure it's constantly being monitored, constantly being retrained, and then the updated system is seamlessly integrated into the production. So I think those are some of the factors and things to be kept in mind when it comes to designing AI and ML based systems.
Yeah, but we are now trying to introduce a human touch into everything that we are just trying to architect. Let it be something like an assistant who just assist you, or a simple task. Probably it can be a email spam filtering algorithm or something. It's all algorithm, but we want a human touch into it. But
Yes.
we are also making sure that we are personalizing those aspects as well, because when you see recommender system, there is a different level of complexity that is involved, because everybody has their own niche, and the system, humans can't understand that, but we are asking machines to understand that, and we are trying to build a solution on top of it. But I wanted to know, how are we building these kind of mass consumer based products? Because when you think of IoT, it's like it's there everywhere. My phone is a device which is much more powerful than the computer which was there in the Apollo machines. And
Yes.
when you think of such kind of an, I think probably my laptop is much more powerful than probably the ISS computer which was there around like 50 years before, probably, if they had stashed it on an ISS, if it existed. But I wanted to understand, like, how is this human touch and the architecture evolving over the course of time? Because a lot of times it's not that same old algorithm which makes sense, because algorithms were there existing, but we have now understood the potential of it. So I wanted to know, how are we building such kind of a complex system which has a human touch into it?
Yeah, I think this is a very interesting sector within the human interaction with machines side of solutions, right? So we've been always longing to find a way by which we can very easily interact with machines. So any of these touchscreen devices made a revolution when it got initially into the market, and the way we are interacting with mobile phones today. So the human interaction is an important element, because that also determines the speed and comfort at which we can interact with these machines and solutions. Um, and the easiest and most familiar way of doing that is through our cognitive services. So similar to cognitive senses, similar to how we do human to human interaction, we want to expect, we are expecting that, we should start interacting with machines as we interact with humans. So that's where I think the advent of some of these cognitive services is an important piece, where we are able to do it through speech, and then through visual cues we are able to communicate with systems. Identity management is all becoming visual these days, and all of these autonomous systems which can interact with people, and it also reduces the effort on labor intensive work, right? So imagine those days when you had a call centers, people were involved, helping customers and end users, and now the first line questions are already taken care of by bot framework. So the bot comes in and allows you to flush out some of those initial questions so that it can filter out, and then eventually take you to the right department where you want to reach. So it's all about, I think, enhancing the customer experience, and doing it in a most familiar way as we interact with humans is one of the most important piece that we are trying to solve right now. So that's where the bot framework are front-ending systems, but they are of course powered by some level of intelligence, which are driven by machine learning analytics, which run in the back end, so that they can at least mimic human type of interaction with people. So the way it's usually designed is there is an element, or there's a layer of cognitive interaction layer, which covers text input, voice input, or it could be language translations that needs to happen at that layer, which is sent back to the next layer, which is your business logic layer, where you want to make sure business solutions are delivered as part of that. So imagine a flight booking system where someone can interact with a bot by saying, I would like to go on a vacation to a particular location. And based on the location information, based on the fact that it's a vacation queue, so the system can automatically redirect the user to a booking system, because it understands the text or the voice message and can automatically identify the intent behind that text, and then push it to the business logic layer, whereby you're driving a business transaction that happens on that layer. So it's a combination of um, sensory information that we gather, and then eventually it translates with the intelligence of cognitive services. It understands text, it understands context, and then it can also push it to the business logic layer, which eventually achieves what needs to be done for the user. So it's a combination of these. A lot of these are seen in human interface systems, in even in manufacturing industries. We are seeing that in retail. So the easy to use kiosk that we have for ordering system, everything is getting powered by AI, and the suggestions that you see when you do online shopping, that's all getting powered by artificial intelligence, because the behavior, but the buying behavior of the user is understood by the intelligence system behind, and then it starts feeding it back into the front end for the users. So it's a combination of few things there. Artificial intelligence in its tight integration with business applications. That's what makes this possible. So we're going to see more and more on this as we are having a lot more powerful models coming up. You might have heard about the GPT-3, which is from the OpenAI. Yeah, so which is the OpenAI project that's been there in the internet for a while now. So which does an enormous number of things. It's about text translations. It's about understanding the intent. It's about summarizing a whole big story into a small summary. So it's almost getting into human intelligence level when it comes to managing text on that. So that's one simple example. So we are, I think there are a number of models that are constantly coming, which is making it intelligent. We might have seen the announcement of the Tesla bot as well. So the intelligence of how a Tesla car drives itself, a similar logic is what is being looked at on the bot as well. So the applications are enormously increasing, and everything is to do with the human interactions. So I think it's going to be fun for us to see what's coming up.
When you told about this Tesla bot, I still remember 2018, 2019 when FSD computer came into the market. That was the first prioritized neural network based engine that I ever saw when it comes to the compute. And that was because Tesla had outsourced their entire compute engine for NVIDIA, but NVIDIA was a generalized market for all the customers. Like they are in gaming, they're in all other marketplaces, but Tesla needed something beyond it. So they started building their own FSD computer, the fully self-driving computer. That's what I feel. We are somewhere architecting, but there is still some canonical problems that are yet to be solved. Because there are some worse than the best practices that you might have seen, but I might have not seen. I might have heard about it, but I want your insights on these, because I feel there is still a lot of canonical problems that are yet to be solved. What's your take on this?
Absolutely. I think it's like I mentioned before, I think it's the speed at which we have adopted something which is still in the making. So that's about how we can use a developing system in an existing model that we already have. So software development and software development lifecycle management has been a matured process. So we know how it works. We project manage things. But there's a new entity of machine learning and AI coming into picture, and it's already getting into production. So I think the important challenge that we have that we need to manage is, apart from the framework and the legal aspects that we need to cover, it's a new technology, it's a new model. Governments will have to adopt to some of these upcoming technologies so that sufficient cyber control is emphasized in using some of these technologies. Think of the deep fake that's happening in the internet today on the media, right? So that's a kind of a double-edged sword. While we have technology for doing some of these um, the the media related stuff, but at the same time it's also dangerous and could be misleading for the entire public and generations who are using this technology. So there has to be a framework around some of these. The challenge here is how do we interface some of these upcoming technology into the existing model, into the existing systems. So we have an existing framework that's been governed by security, that's been governed by policies, that's been governed by legal, and we have a small block that's coming up, which needs to align to some of these framework that's already existing, and at the same time will have to provide a seamless integration into some of these existing systems. So I think the first challenge is because it has to integrate with existing systems seamlessly, and at the same time carry forward on some of those value systems that we have designed on top of those existing solutions. So that will be the one big challenge, because of which we are seeing some of those fundamental problems still arising on adapting to some of these technology. And the other important piece is learning the right way and applying these technologies for the right purpose. So with identification of new technologies like the nuclear power, we could do anything, but applying that for the right purpose is an important piece. I think AI and ML is very similar to this, and there is a lot of room for errors which needs to be controlled and managed. There has to be an in-depth knowledge on how to implement and use these systems before putting them into practical applications, because like I said, open source allows anyone to go and play around and use an existing model and build that as part of their application. But does the person who's using that model is completely aware of the bias that has gone into the model, the features that were used to train the model? So there has to be an absolute understanding of what was involved in designing the model. So the model is not a static entity. So it has to be constantly evolving because the data is constantly changing. The features or the parameters around the model is constantly changing. So that's where we have this feedback loop of constantly retraining the model and making sure it's more relevant to what we need for our solutioning. In software systems, it was not that very frequent where you have to upgrade your version, make sure you come out with, of course, security patches are important, but you had a slightly lower frequency at which you would go and upgrade or change the version of your applications because things are not moving so fast. But whereas from an AI perspective, everything is driven by data. So the data is constantly moving through the model, and you want to make sure the drift that's happening is fed back into the model, and the model is retrained for this. So if someone is actually building a very simple AI solution and they don't take into account of all of these aspects, over a period of time, their system is going to do a fault prediction, for example. Their system is going to underperform, or the efficiency of the system will go down. And if that's not been monitored and fixed, then it could lead into a lot more confusions in using the application. So apart from the fundamental problems, I think it's important to understand the dynamics of these new solutions so that the right results can be achieved. So I think that's what is more important for us. As younger generations, when they start using some of these systems, it's important to understand the nitty-gritties of what they are handling, and then design the system appropriately so that you have sufficient controls and legal framework in place.
Yeah, that's true. That's true, because I want to be an engineer who can build the best AI, but I want to always build a sustainable system with sustainable intelligence. It's not about like somebody using my model for deep nude or deep face. That's going to be horrific because I built a demon in front of my own eye. Like I built that demon and everybody is just using it to some extent. But I really wanted to understand, because a lot of times when you think of, there are some news nets, like they produce music, but there are some adversarial examples, like you can use GANs for the security, like the the real information can be made sure that there is a GAN layer which just decomposes all the real values that are being there, and it can give a fake image if somebody intrudes into the system. And GANs have really made a huge trend in the market right now. But I wanted to know, what was the industry trend that really shattered the way we are architecting a solution? Because I never saw what was TensorFlow when it was released as an open source. Because I was in 2015, I was just out of my class 10, and I was never able to understand what was the complexity of it. But when I had a chance to hear some lectures from eminent people who are there in the field for a very long time, there's a huge shift in the mindset which they had. Because 2016, I was in a talk and there was a huge shift. The speaker had to say to me when he was doing the AI exactly 10 years ago, because he didn't think that computers have this as the potential. But now I wanted to know what really shattered the way that we are architecting a solution, because a lot of times startups are now having a huge share today. But I wanted to understand, what is it all about, the thing which shattered the way we are architecting the solution?
Absolutely, absolutely. I think more from an affordability perspective, I think what has drastically changed, especially when it comes to AI and ML, is how could someone design this as well? So in traditional terms, you would expect someone who's been in that space for a while, they have built expertise. Now they understand how it needs to be built. So if we have to build weather forecasting system, we had data scientists, we had statisticians who were working on this. And then, of course, the developer comes in and wraps it around as a solution. And then eventually we have a system. But what's happening now is we are getting to a level where AI systems or models can be developed even without a familiarity on data science and ML. So things like auto ML systems, which can automatically generate models based on the data that you have supplied, and it gives an output for users. So for designing a model, you don't need the expertise. You don't need to be a data scientist. You don't need to be an ML engineer for you to design a model for solving a particular problem. So if you have a forecasting scenario that you need to build an AI model, all we need to do is today send the data into an auto ML system that can automatically look at the data, create its own features, and then test this across a number of models automatically and pick the most efficient model, and then give that as a final model, which is fantastic and interesting. We haven't done this in the last 20 years when developers are sitting and writing code, because they would always have to write code. But for building a model, as again someone sitting and building a model, today we have AI systems building AI systems. So we have machine learning understanding and feedback loops that can actually create a machine learning system. And that's how I think it's becoming increasingly popular, and it has disrupted the way we are building solutions as well. And that's one important reason why people are very quickly adopting to this, some of these technology. So when I talk to a lot of smaller organizations, even where they don't have data scientists, where they don't have data engineers, they can already start thinking of an AI-driven solution as part of their business. And that's coming because of the affordability and of the technology. And at the same time, how quickly someone can build some of these solutions. Second thing is about the open source nature of this. Someone builds a model, throws it into the internet, people can grab the model, they know the schema of the model, so which means they can readily start implementing some of these into the system. So the open source scenario has been there for quite some time. We do that on code as well when we build software applications. So there are a lot of open source code that you can grab, open source applications that you can grab. The speed at which we have made this kind of open source in AI and ML is tremendous. So we would have expected this to happen in about 5 or 6 years time, but we have done that much quicker. We've never had a software that writes software before, but we have AI models that can build AI models very quickly. Given the nature of the technology, we are able to exponentially speed up in terms of how these technology can be made available. I think that's what has drastically changed in terms of how some of these things are happening. If you go back and look at your mobile marketplace, the number of AI-driven applications, it has exponentially grown. I think that's because of the fact that we can architect some of these much faster as compared to how someone would start from scratch and build a traditional application when they have to do this. So the release time frame for some of these models are constantly dropping or constantly reducing, so that your time to production is much shorter as compared to what we do in traditional methods. I think that's a very big change as compared to what we did traditionally when it comes to architecting. So as far as we can ensure the responsible AI principles within the development cycle, I think we are in a good shape in terms of how we can very quickly leverage on some of these capabilities and put it into use for the benefit of the community.
Yeah, that's true. That's true, because it's not about the hybrid cloud which makes the deployment easier. Forget the fact that there is an hardware, but what have you done in the initial stages of, because we are now making it more data centric. We are now making it more thinking of model centric, which was actually like a long time before. As soon as you have an Onyx or an HPI model, just throw it on the system. But today there's a paradigm shift in the mindset, which we are architecting in a different way. It's more of a data centric, how much data you have, what's the security aspect that is being covered over the course of time. I think this is basically what we are required today. I think you covered a lot of things. I think thank you so much, sir, for giving me this podcast. I know that I was late by 10 minutes, but we covered a lot actually.
Thank you. Thank you so much for having me here on this podcast, Vishwas. So it was wonderful. It gives me time to actually reflect back on what is important and what has been exciting so far. I think we have something very exciting way ahead for us. And as far as we can responsibly build some of these and use it for the right purpose, we would have absolutely used the technology for the for the right purpose and in the right direction, I think. So yeah, it was a fantastic evening for me as well, just to reflect on some of these important aspects on AI. I just thoroughly enjoyed.
Thank you so much, sir. Thank you so much.